All right, welcome to a non-graphing section, ladies and gentlemen. This should be pretty exciting. We finally get to do some algebra and leave graphing behind for a while. Notice we're skipping to 10.4 because 10.3 was to solve by graphing. And in the real world, that just isn't a real thing that anybody usually does. So we'll jump into 10.4 and talk about how we can use square roots to solve these quadratic equations that we've been working with. Today, we are talking about forms that have only an a and a c. So notice that bx is not there, so b is 0. We're only talking about these two forms, or these two variables today when we solve. And the trick, like with any equation that we're trying to solve, always we want to isolate our variable. So we want to isolate x squared in this situation. And once that is there, to undo a square, we're going to square root. Okay? Now notice right here I said if allowed. If allowed, what can't we take square roots of? If you said negatives, you are absolutely correct. So if allowed, we cannot do square root of some negative number. Okay? This is not allowed. So if you end up with something like x squared equals -4, you will have actually no solution, not any sort of answer. Okay? Let's check out what some of these things look like. So here's some equations for us to solve. They look pretty fun. So our first example, we want to isolate x squared. So to do that, I have 3x squared, so I'm going to divide both sides by 3. So I have x squared equals 9. All right, then we're going to square root both sides, because that's how we undo x squared, remember? And this is going to give me x equals plus or minus 3. Now the reason this plus or minus comes in there is because if I take a -3 and square it, I get 9. And if we take a +3 and square it, I get 9. So anytime that you take the square root of both sides of an equation, you have to remember to include that plus or minus symbol. If you don't, it is actually wrong, so we don't want to get a whole bunch of wrong answers. Okay? Of course, you can plug these things back in and check to make sure that they do work as solutions, and this first one actually does. Let's look at our second one here. P squared plus 12 equals 12. Okay. What should we do first? Isolate p squared. So how am I going to do that in this case? We have p squared plus 12, so I need to subtract 12 from both sides. That will give me p squared equals 0. Then, to undo a square, I square root both sides, and now I have p equals, what's the square root of 0? 0. Okay, and plus or minus 0, while not wrong, is just a little bit extra. You don't need that plus or minus because 0 isn't really positive and it isn't really negative, it's just neutral. So no plus or minus there. And our last one, we have a squared minus 3 equals -4. So here's an a squared. I want to isolate that. It says -3, so undoing that would be plus 3. So that's going to leave me with a squared equals -1. Now on the first page of notes, I warned you about this situation happening where we would have a squared equals a negative number. If you forget though, and you try to take square root of both sides, and you just type that into your calculator, any calculator would work, it will tell you that there's some sort of error, okay? And error doesn't mean you write error as your answer. It's telling you that, in fact, there is no solution. So your answer needs to be the words no solution. All right? So, in general, just from these three examples, are there any conclusions we can make? Maybe, if we were in the classroom talking to each other, maybe we could talk about how sometimes there are two solutions. Sometime, like with our second example up there in green, we only have one solution. And with our last one down here in red, we ended up with no solution or zero solutions. And that's actually kind of special with quadratic equations. We can have all these different types of options. 2, 1, or 0 solutions, all from one equation. Super cool. Let's practice some more. Okay, here's a little graphic of that situation that we were just talking about with the different solutions. If we have x squared equals some d value, so once we have that isolated up here, in our first one we had x squared equals 9, here we had equals 0, and there we had equals -1. If we have that, this little table tells us what we have going on. Sorry, I just wrote on it. What's going on, why there are 2, 1, or 0 solutions. So this very first one up here, when d was positive, we have a situation where our line intersects the parabola twice. Remember, that's not a parabola, it is parabola. Okay, so we have two solutions, one here and one here. When that d value equals 0, that line is right here, so we have this one solution right there at the vertex. Remember, that's called a vertex. And then the last case is when we have that value equals a negative, and that's our blue line down here. And notice our parabola doesn't cross that blue line at all. So no solutions, right? Okay, let's practice some more because I'm not out of examples yet, and we're having fun. So 2x squared equals 8. 2x squared equals 8. What should we do first? I agree. We should divide by 2. So let's do x squared equals 4. And our next step is, you got it, square root both sides. So we are going to have x equals 2, because the square root of 4 is 2. But what special thing do we need to remember? We need to remember plus or minus before we box in our answers. Okay? Don't forget. Here's another one. M squared minus 18 equals -18. So we're going to isolate m squared right there by adding 18. And then I get m squared equals 0. Next step. Square root both sides. And friends, what is the square root of 0? 0. No plus or minus needed. The third one, minus 12 to isolate b squared. And I get b squared equals -7. Square root both sides. Type that into your calculator and you would get square root of -7 as an error, so we write no solution. How do you feel? That's kind of making some sense to you? I hope so. There's more. Should we do a couple more? Okay. You try these. Pause the video, try these on your own, and then check them. That would be a really good idea. Okay, pause now. So the first one we're going to divide by 4, and we have z squared equals 9/4. I don't want to turn that into a decimal or anything like that, because I'm pretty sure I can just take the square root of this like we would have done a couple chapters ago, and take in the square root of 9, which is 3, and the square root of 4 separately, which is 2. So this would give me 3 halves, And remember to put your plus or minus in there. Next one is very similar. We're going to divide by 25. S squared equals 49 over 25. Both are perfect squares. So when we square root, we get plus or minus 7/5. This one here, we're going to add 11 to both sides. This one's a little trickier, it looks like. 7 plus 11, 18. Now we have to divide by 3. So we get x squared equals 6. And that is square root both sides, plus or minus the square root of 6. Now 6 isn't a perfect square, so we can absolutely leave our answers as a radical. If you want to type square root 6 into your calculator, you certainly can, but it is an extra step that I don't really need you to do. And this last one on this page, add 10 to both sides. 2x squared is equal to 16. Divide by 2. X squared equals 8. Square root both sides, so we get plus or minus square root of 8. 8 itself isn't a perfect square, but if you remember when we simplified radicals, that was root 4, root 2. So this would actually simplify to 2 root 2 as a fully simplified answer. Again, you could do the decimal if you so choose. Okay, unfortunately, you guys don't get to go work on the boards since we're not in the classroom at all. So these examples you can certainly practice on your own, and I will make sure I have the notes uploaded to PowerSchool Learning so you have the answers for you. Enjoy your homework, give it a good shot, and let me know if you have any questions. Have a good day.